Hello everyone, this is NetMaven. Today I'm going to make a lab for Cisco ACI 5.2. We're going to make some initial configuration to the ACI, get familiar with the user, with the initial setup process, some fundamental concepts, and we're going to connect the ACI to external networks. So the lab we have is the ACI Apex Simulator version 5.2. We have spine 1, spine 2, leaf 1, leaf 2, 3 Apex, and we have vCenter 7.0. So first of all, configure some basics. The basics includes bring up the spines and leaf switches. The API, the APEC UR automatic discovers are all new switches that are directly connected to any switch it currently manages by LLDP. Each APEC in the cluster or first discovery only leaf switch to which is directly connected. Then after the leaf switch is registered with APIC, the APIC discovers all spine switches that are directly connected to the leaf switch. As each spine switch is registered, the APIC discovers all the leaf switches that are connected to the spine switch. So we call this as a cascaded discovery allows the APIC to discover the entire ACI site topology, and it will automatically configure VXLAN, ISIS, multicast, and a few more in just a few simple steps. So first, let me log out, and we'll log back in. So the first thing I find is the what's new, and click begin the first time setup. We're first beginning a Fabric membership. As in here, we're finding a leaf switch, click register. Node ID 201, leaf 1, and I'll submit. And it's getting registered. Just a minute or so, the device is added to the list of registered device. And for the discovered device, we'll find the serial number 103, 104, and we'll click use register one, tap 103. And node ID will make 11. I'll make spine 1. Click spine, node type, and we'll submit. This gating discover spine switches for 104. I'll make node ID 102, spine 2, and it's spine. Submit. Now two spine switches are getting registering, and we'll soon see the registered spines. Now I'm seeing node 202. That 202 is 9300 switch. Then we'll get registered to my second leaf. Node ID 202. Switch name or name is leaf 2. Leaf. Click submit. Let's keep refresh here. I'm seeing 3 switches, 1 leaf, 2 spines. So I will just allow a few minutes, and for completion of the leaf and the spines, they all got registered. I shall go ahead, click continue. So the next thing I'm doing is the BGP, the ACI sites route refactors are using multi-protocol BGP and BGP to distribute external routes from external routers to every ACI site members. So to enable route refactors, then in the ACI site, I must configure spine switches that will be the route refactors and provide AS number. So for redundant purposes, more on one spine is configured as a route refactor mode. So let's click the BGP. BGP, I'll put AS number 65000 and we choose both spine and click Save, Continue. To configure BGP is as simple as it is right now. Back to the BGP here, everything's configured. We should configure NTP. Time synchronize that plays a crucial role in the ACI. So well, from validated search to keeping the consistent log files across device. So it's important to sync my ACI site to one or more reliable time source. We're gonna choose here at my NTP server and check preferred. Update, save and continue. Next is DNS. DNS server, add one. Click preferred, update, search the domain. Check default, update, save and continue. We skip proxy and we'll continue with out-of-band management. Out-band management provides the management communication through configuration of dedicated physical interfaces on the EPIC and ACI switches. One ACI site is initialized and discovered. The OOB address can be configured for the switches. And we'll go select all unconfigured nodes. I'll configure OOB for selected nodes. And it's asking to start with a range. Then everything will be automatically assigned. Save, continue. Review everything. Here, down there, switches are configured with OOB address. We go make some global configurations. Looks all good to me, and we'll save, continue. Let's close it. And so let's review the fabric inventory. By now, we should have 4 switches. Go to fabric member here. Now I'm seeing 4 switches, 2 spine and 2 leaf switches. And they all show active. And expand port 1. See the physical interfaces and how they connected to each interface. If this doesn't show a clear picture, let's go to topology. Loading up, and this is a very clear picture of your topology. What I should configure next is the creating a VMM domain and connect to UCS with VM EXSI server to the ACI. I will integrate and connect to VMware infrastructure running on a UCS to our Cisco ACI site. So when implementing ACI, my considerations should be no different than when I implement a traditional network. To implement a physical connection in the ACI, so first of all, I define this domain and VLANs, also AEP interface profile, IPG, interface policies, switch profile. So all of that will be in the access profile policies. Before that, I'm gonna do is creating the VMM domain. Click virtual networking, VMware, and I'm creating vCenter domain. I name it as my vCenter. Virtual switch VM vSphere VDS, that's fine. And we'll associate, I'm gonna create a EP, VMware AEP. We'll click next, finish. And it's telling me to create a VLAN pool. VLAN pool, we're gonna choose VM pool dynamic allocation, add a block VLAN 1000 to 1500. Keep everything default, should be fine. Okay. Okay. Scroll down and we'll find the vCenter credentials. I'll add it. vCenter username. Click OK. To add, scroll down here to the vCenter name. We're gonna use my cloud DC. Hostname VC1 virtual VM center and IP. With data center, say my DC. Associate it. Just click it. vCenter user. All right. Click OK. Let's see what else. Keep scrolling down. Port channel mode. We're gonna to make MAC pinning. So MAC pinning when connecting the UCS blades, so it contains LACP is not supported at the server level, so we use MAC pinging. vSwitch policy, we should use LLDP, and that's it. Submit. Now I'm creating VMM. I don't have virtual vCenter, but actually if you do, your expanding hypervisor, you'll see the virtual machines listed right here, and you'll find your port group listed here. Then let's continue if I don't have it. then we'll go to fabric. We're talking about is the ports. All of these things I will configure. Access policies, and we'll expand the fabric. And access policies, interface, leave interface, polyscoop is to create a VPC interface polyscoop, and on the VPC interface, we'll create VPC IPG, creating VPC IPG, the name UCS VMware AEP, we created already, CDP, we want to turn it on, so we're going to say CDP on, LLDP, I want to turn it on. All right, and for link level, let's give it 10 gig. 10 gigs fine. 10 gig. Auto negotiation, I don't want it. And give a name 10 GPBS. Let's submit. Next, port channel policies. We're going to create one. ALACP is active. So make TCP active. Submit. Let's go to step 2. We need to find MCP policy. So MP standing miscabling configuration. So it's best practice to enable it. All right, so let's enable it. We should say MCP on. Do we have STP interface policy that's created? So this we'll say BPDU guard on. I want to turn it on. BPDU guards on. Submit. With all that, finish. Now I have IP my VPC. Now I will use the wizard to create the required configuration to connect the UCS chassis and the VMware EXI servers inside. So UCS fabric interconnect connects to the interface 1/1. Let's go to a quick start, interface and policies. We'll be selecting my nodes for leave. Not like let's create interface. Leave switch, 2 of them. Interface 1/1. And that's VPC. Creating is using the UCS IPG. When I selected 1/1 and both, they will name at both switch 201, 202, and port 1 will be on both leaf switches. And after populated, I'm seeing the advanced. Looks good. Click next. And they're creating profile, creating this port selector. All that will be created by the quick start wizard. Let me check the switch profile created. Interface profiles created. Selector is also created for the interface 1/1. All right, so what I do next is to verify physical interface. Go to Fabric and Inventory, expand port 1, click to the leaf 1, expand its interface, and we'll go to physical interface. Now you see 1/1, 1/1, 1/1. We should see more. 1/1 is configured and status up. Let's verify my VPC interface. There's configured. Keep doing that. Now I have each 1/1 configured for VPC interface. Same interface I could find on the leaf 2 also. Here you go. Same configuration on E/1/1. If now I have EXSI, we can log into the vCenter, then now I'm going to find my vCenter VDS. So it's virtual distributed switch there, and we're going to assign the host, which way I'll choose which virtual machine I will assign to this network and to assign the interface to it. The next task what I would do is create a tenant and application profile. So a tenant is a logic container for application policies that enables an domain-based access control. So tenants represent a unit of isolation from a policy perspective, but it does not represent a private network. Tenants can represent a customer in service provider settings, an organization or domain in an enterprise setting, or just convenient group of policies. So a tenant contains VRF, EPG, we will call it the application profile that contains endpoint groups are called EPG. And our contract filters between the EPGs will be contract has filters, and bridge domains. Remember the in VXLAN we have VNIs, L2 VNIs, right? And we have outside network within B in ACI we call L3, L2 out. So without saying all that, let's just click tenant. So I'll show you 3 default tenants. So first tenant you're seeing is the common. So the common tenant is provided by the system, but it can be configured by by our administrator. It contains policies that govern the operation of the resources accessible to all tenants, such as firewalls, load balancers, L4, L7 services, intrusion detection appliance, and so on. Next, I want to say the infrastructure tenant is provided by system, but can be configured by administrator. So it contains policies that govern the operation of infrastructure resources. For example, VXLAN overlay, MPGP, MPBGP configuration. It also enables administrator to selectively deploy resources from one or more user tenants through the policies. Next one, managers. Management tenant also system wide and can be configured by individually, and it contains the policies that govern the operation of the ACI nodes. Management functions are used for inbound, well, if you configure inbound or OOB configuration, will be here. All right, remember in the beginning we configured the auto band. So what reflects is right here. Well, I shall show you right here. Do you see the IPs for epic and the leaf switches, spine switch, the IPs? It's configured already here. That's for the management tenant. Of course, what I'm gonna create is the tenant. The tenant I'm creating is the user tenant defined by myself and according to the needs of my requirements. So the customer tenant or user tenant contains policies that governs the operation resources as well as applications database. We have web servers, network attached storages, and virtual machines and so on. So let's take a look at it here. So there are four methodologies for setting up my ACI policies. They are A, B, C, D. Option B and C I recommend some methodologies. In option B, the subnet can be used by any tenant. Option C, subnets cannot be shared between the tenants. What we'll do, the option D, where everything is created in a single tenant, including VF, bridge domain, EPG, AP. Creating my tenant. After creating my tenant, I'll be creating a VF. VF is L3 contact or private network. It provides IP space isolation for tenants. Each tenant can be one or more VF, can have one or more VF or share one default VF with other tenants when there's no overlapping address between them. So it's independent route table. And we'll go expanding networking and create a VF first. Everything is out layer, inside layer of VF. VF 001. Next. Go Paris. I don't want to create bridge domain for now. Let's create VF. Close it and go to bridge domain. So what is bridge domain? A bridge domain is a unique layer 2 forwarding domain that contains one or more subnets. And remember the VNIs in VXLAN. Each bridge domain must be linked to VIF. It has a VIF. Here are two bridge domain are created. They are named in alignment with subnet address which they contain. The bridge domain can contain multiple subnets. Align their naming with subnets they make them simple to understand. So we'll be using a bridge domain like this. Just give a name and pick up the VRF, click next, and we'll give it gateway to align with the name. That's one. Keep everything default. Next. Okay. Create next one. Pick VRF. Give it address. Okay. Okay. Next one. VRF. Give it IP. Okay. Next. Finish. Now I'm creating 3 bridge domains. If you go networking, I'm seeing 3 bridge domain are created in a diagram here. We shall not create. Next is the application profiles. So application profile is a container. It contains the visualized application layers like Epic then automatically renders the network. So what I mean is the application profile enables me to approach the network resource pool in terms of application rather than infrastructure building blocks. So application profile is a container that holds the EPGs that are logically related to one another. EPG can communicate with other EPG in the same application profile with EPGs in other application profiles. So inside, outside EPG can be communicated. So to deploy application or network policy, I must create required application profiles, filters, and contracts. So typically, Epic hosts 3-tier application within a tenant network. So application is implemented by we have 3 servers: web server, application server, and database server. So you understand what I mean. Go to tenants, application profiles, so create AP. Create AP, we call it my app, submits. That will create a container application profile. That's it. And we're gonna to create an EPG now. EPG for the first subnet, 192.168.20.0, or just 20.0 for short. And we're gonna to create EPG name 20-web. This be web EPG. Now pick my bridge domain 20.0. Let's finish. So now we say I don't have a domain or VM or bare metals associated with this EPG. So we'll go to application my AP topology. We'll find the VMware, drag to it. Before I do so, I should go to domains, associated VM. I can see virtual machine VM Datacenter domain is associated to it. We should go ahead to create more EPGs. 21 is for my application bridge domain. 21, finish. Go to domain. Submit. Next one is for my 22 database. For my bridge domain. Now go to my topology in AP. I'm seeing virtual machine domains to the bridge domains. If I have a vSphere vCenter, I go to my VDS virtual distributed switch, expand it, I will be seeing the EPG created under them. Okay, so we skip a lot because I don't have virtual center. Then we'll be working on the contract. We have app, bridge domain, and web. For them to communicate with each other, we need a contract. Contract has filters. Each filter contains one or more entries. Each entry is equivalent to a line in the ACL access as control list that is applied to the leaf switch to which endpoints to within the endpoint group is attached. So contract has filters. Filter has subjects and it has actions and protocols, source, and destinations. In my enterprise right here, tenant 1, I have database to communicate with application. Database will communicate to application. Application communicates to the web. Let me do it in topology. First, we'll drag the contract to 22 dB, and the contract I'll give it a name. Wait a second. I'll make contract gonna be application to dB. We'll uncheck no filters. Here creating some filters. Name my circle. IP, TCP, destination port. No, it's 3306, 3306, update. Click OK. To verify that, go to contracts. I don't see it created. All right, let's create it in a normal way. Filter. we are creating it in a normal way without a drag and drop, and let's do it. Update. Okay. Now contracts created. What we're trying to do will make very easy to show you here. Let's see if we can drag and drop. Nope, I can't. Anyway, so make sure click database, provide contract. It's providing, then you will see the difference will be consumer contract. Now we're making provide and consume. Go to my topology. Now you will see the difference. Who's providing? My database. Who's consuming? Application. They are consuming this database, my circle. Okay, next contract will be web to application. Web to application. This 20 to 21. Okay, let's create. Create a contract. Web to app. Gonna add a subject. HTTPS. Contract is made. And we'll go to web to app. First, app will be providing the contract. And web is consuming app. Go to topology. Let's see if it's made what we desire. Okay. Now perfect. It's perfect in sense in a logical way. And in the next task, let's think about integrate and migrate legacy L2 networks to ACI. So as a network designer may need to extend the L2 domain beyond the ACI fabric. These circumstances may include connecting existing layer 2 network switches to ACI or extending L2 domain to an existing data center infrastructure DCI platform such as N7K and or ASR 9K routers that provide layer 2 DCI service to a remote site. So sometimes users simply need to assign a port to an EPG in order to connect a switch to ACI or even connect a hypervisor and its virtual switches without VM integration. They're for example, the bare metals, or simply just virtual machines, EXSI. When we think about extending, there are two main ways to extend L2 domain beyond the ACI fabric. First, extending EPG out of the ACI. So a user can extend the EPG out of the ACI by statically assign ports along with the VLAN IDs to an EPG. So this can be one to one VLAN EPG mapping if connecting an existing environment to an ACI one as shown in this diagram, right? Since I'm extending EPG, it's just extending the EPG. No contract is needed in order to have VLAN to EPG communications. No contract. Second way, we'll extend the bridge domain out of the ACI fabric. It's an add-on option to extend L2 domain is to create an L2 out. L2 out connection for a given bridge domain. For example, this L2 bridge domain, L2 out bridge domain. The difference between extending the VLAN EPGs is that it requires a contract between extended bridge network and EPG sharing the same bridge domain. For example, here we have a bridge domain. Between the L2 out, we need a contract. But extending here is no contract. So I can extend the EPG beyond the ACI leaf by statically assigning a leaf port along with the VLAN ID to an EPG. After doing so, all traffic received on the leaf ports with the configured VLAN ID will be mapped to the EPG, and the configured policy for this EPG will be enforced. So the endpoints need not be directly connected to the ACI leaf port. They can be behind the layer 2 network as long as the VLAN associated with the EPG is enabled within the L2 network that connects the remote endpoints to ACI fabric. So this is the easiest way to an existing environment and migrate gradually. So first doing this, we'll first create a physical connection to the leaf switch. As we touching the switches, we'll be creating some VLANs and physical domains. Go to access policies, and we'll go expand the physical and external domains. Go to physical domains, creating a physical domain. There will be legacy switch PD physical domain. Create that. Let's remove it. I'll create again. We're gonna create a AEP along with it. And create this. And we'll create the VLANs. Legacy VLAN pool. choose static allocation, make it 10, static, okay, submit. Submit this also. We're creating physical domains, AEP, and a pool. Okay, static VLAN 10 for legacy pool. We'll be creating next the access policies. Expand interface, leave, IPG, let's create is legacy switch PG. AEP. That's it, submit. We'll go to quick start. I'll configure interface. Interface will be connecting us the leave or connecting to this switch. Leave 201, interface 110. We'll make to with interface 110 and pick an individual, and that's the PG. Click next. And finish. Okay. And in the other switch profile is created for leave switch 202 and port number is 1/10. So we want to integrate legacy networks to ACI for our web EPG, and we need to enable flooding for L2 unknown unicast as well as ARP flooding within our 192.168.20.0/24 bridge domain. Tenant or extends here. Go to policy. Here I'm seeing L2 unknown unicast. Make a flooding. And do I see ARP? ARP flooding enabled by default. That's fine. And I'll submit a change. Submit. Now let's go to my AP. My APB. Go to topology. Pick up the port and the switch. Here you go. VLAN 10 at trunk, that's fine. Close it. Now I have bare metal connected to the 20 web. Now I'm seeing a bare metal switch to my bridge domain web, and the VLAN is 20. Now I'm gonna to add VLAN 20 to legacy VLAN pool, and then associate the bare metal legacy physical domain to port 1 node 201 Ethernet 1/10 with VLAN 20 to 21 app EPG. I'll make sure I have L2 unknown unicast and ARP set flooding within the cooperating bridge domain. Policy 21. Set unknown flooding, ARP flooding, fabric. Adding VLAN 20, static 20. Next, go to quick start, create an interface, pick the switch, I have the switch profile, go back to tenant, networking, bridge domain 21. Oh, sorry. Go to EPG, now search the physical domain, static port, topology. I'm seeing the bare metals on my 22 app. So lastly, we'll create and integrate a L3 connection in ACI. APIC includes a simple create L3 out wizard that provides a straightforward walkthrough for configuring an L3 out, which defines how ACI fabric connects to external L3 networks. So in this step, I will integrate a L3 connection in ACI. Doing so, I will first need to configure physical network connections. Navigate to Fabric, access Profiles. We are going to make is physical domain external domains or create L3 domains. Name is L3 out. Creating AEP. L3 domain AEP. Clicks next, finish. We'll leave the VLAN pool field blank because it's not needed. I will need to create the pool for L3 connection with the SVI and sub interface. So let's just submit. Let's go to quick start interface, creating an interface. Choose both leaves. Interface 1/5. Here we're gonna add L3 out. L3 out. Still individual interface type. We'll be creating a leave access port policy group. This one L3 domain PG link level 1 Gbps. Turned off auto negotiation. CDP. We don't want a CDP. We do want a CDP. CDP on. We have created AEP. That's it. Submit. Clicks next. Finish. Okay. Now we should create is the L3 out using the L3 out wizard. I make necessary basic configuration for L3 out components. I'll make identity, node, interface, protocol, and external EPG. So go to tenant. I will go to networking, L3 out. We're gonna make L3 out. We're using OSPF, by the way. OSPF, VRF, L3 domain. Pick OSPF. OSPF will make area 0. Go ahead, click next. We'll note, make a note, root ID 201.201.201.201, interface 1/5, IP address. Let's leave one. I'm going to hide it. Add one. Yeah, add one. And leave two. Interface 105, 1/5. Face also. IP. Click next. No protocol. Next. You're creating an EPG. L3. out, provide a contract. Right, we need a provide a contract, permit to L3 out, scope VF, that's no change, and subject. And ICMP. Say OK. Submit. Click Finish. Oh, go back, back. Regular. Area. Finish. Now I'm seeing L3 out OSPF network is created and it has EPG also. External EPG L3 also created. Now we need to provide external connectivity to an application profile. What we'll do, I'll go to bridge domain. I'll pick up my database. Subnet. This one will be advertised externally. Click submit. This is not a bridge domain. It's a bridge domain 20.0, and we'll advertise it to it. Oh, as you know, this subnet belongs to bridge domain 20.0, and this is my 20 for web. Good. And we still go to this bridge domain, go policy, scroll, should go L3 configuration. Here you see associate L3 out. We'll pick it at L3 out, update, just like that. And you know I have consumed provide contract here. You should provide a permit to L3 out. So my L3 external EPG is providing that. And we're gonna to consume this L3 out contract. So we'll make the connection with contract. Now let's take a look at my topology. Have a big picture here. I should see my L3 out connecting to 20 web with a contract permit to L3 out. So this contract is now in place, allow traffic to pass to the L3 out connection. So that concludes all my labs for ACI. We have done a lot in this lab. Just make summary with this membership, leaf switch, spine switch, with the basics for BGP, NTP, DNS, Aruba bound, and we create a VMM domain and we registered EXSI server to ACI, and we create a tenant, bridge domains, 3 bridge domains. Remember, I have EPG, 3 EPGs, and we sign the contract to allow database to app, and a contract app to the web. And then when we migrate a L3 network to ACI, we're using extending the VLANs, and we have L3 out for my 20-web EPG to provide external connectivity. So if you enjoy my video, please consider subscribing below and leave a comment. Until I will see you next time.